Now, of course, the right microbiota is important for gastrointestinal function, but also for immune function, because some of these bacteria, especially the ones that can ferment and these oligosaccharides, they themselves produce a lot of components, metabolites like short-chain fatty acids, but also other metabolites that are small molecules that can have an effect on the intestinal wall and the immune system. Yeah, breast milk contains a lot of components that feed the microbiota, in a sense that the bacteria that grow when they see complex sugars, as you see in milk, the human milk oligosaccharides, you preferentially see that bifidobacteria and lactobacilli, that are generally considered as beneficial bacteria, that they start growing more than let's say the E. coli that we often see as maybe being less beneficial, even though we all have a lot of them, I should add. And that period of the developing microbiota actually takes weeks and months before it stabilizes, I think around 2-3 years of age. And there the content of nutrition is of course very important in steering and supporting the development of the right type of microbiota. The oligosaccharides are very important. The oligosaccharides are complex sugars that are not digested during normal digestion in the small intestine, and they typically reach the large intestine intact, so not digested. So they can act as a substrate for bacteria, but only for the bacteria that have the right enzymes to actually eat and ferment these oligosaccharides. And that's typically bifidobacteria and lactobacilli that feed on these oligosaccharides. One other thing that these oligosaccharides can do is actually bind to sugar-like receptors on the gut wall and on pathogens, and in that way directly interfere in the binding of potential pathogens to the intestinal wall, which is quite different from feeding the right microbiota. The interaction between the bacteria and the immune system, I think it's depending on the situation. If your gut is intact, then the microbiota in your gut are just sitting inside the intestinal tube, and they are completely separated from the epithelium and from the gut tissue beneath that. So they do not pose a threat, and there the immune system doesn't have to do much. Now, if you do get a small wound or an infection in your gut, then the microbiota in your gut can become invasive, even though it might not be a pathogen, but because there is a hole in the gut wall, they can come in and cause infection. But on the other hand, the interplay between the microbiota and the immune system, on the one hand, the immune cells in the gut, especially the dendritic cells, they have dendrites, which are basically pieces of cell membrane that are very flexible and that can actually stick through the epithelium and sample what's going on in the intestine. So without having a hole in your intestine or a leaky intestine, the immune system knows what goes on in the gut. That's one way to do it. And then when the microbiota are metabolically active, they secrete small metabolites into their environment, and these small molecules, they can easily pass the barrier of the gut, and they can have a direct effect on the immune cells, like the short-chain fatty acids or AHR ligands or other small molecules. So I think the messengers between the bacteria and the immune system are, at least from my point of view, most likely to be these small molecules, the small metabolites. And when you talk about the intact bacterium, that becomes more of an issue when it becomes invasive. So I think the composition of the microbiota is one thing, and the metabolic activity of the components they produce is maybe even more important than the composition itself.